So in this video, I want to go over the solution to the problem soil moisture characteristic 1. We're given a soil moisture characteristic for a soil shown below, and we have to answer these 4 questions. So question 1 is, how high is the capillary fringe? So here is the curve in more detail. The capillary fringe is that region above the water table at negative pressures where the pores are saturated with water due to capillary action. And we can find that. Remember that we can imagine this is the elevation above the water table at under hydrostatic conditions. And so we can see here that the porosity here, that's the porosity when the pores are completely filled. That's equal to 0.33. And notice the pores remain completely filled as we go up to an elevation of about somewhere in here, right? So that elevation corresponds to, if that's 0.01, this is 0.1, that's 1, that's 0.1, 0.2, 0.3, something on the order of 0.3 meters, which is equal to 30 centimeters. That will be the height of the capillary fringe. Next question, how much plant available water does the soil contain? So plant available water represents the water between the moisture contents of field capacity and the permanent wilting point. So field capacity can be found as the moisture content corresponding to a matrix suction or a tension head of -1 meter. So that's right over here. So what I'm going to do is look on my curve for the moisture content corresponding to a suction of 1 meter. And there it is right there, and that corresponds to 0. So this here is the field capacity. So I'll write that up here. The field capacity is equal to, looks like 0.32. The permanent wilting point is found at a matrix suction of about 150 meters. So that's 100 right here, 10 to the second. This is 200. Remember how a logarithmic axis works. So 150 is sort of, it's actually about 2/3 of the way up. So it's somewhere in here like this. And I'm going to assume it's close enough to, well, let's just say right about here. It's going to be hard to read this exactly. So this is the moisture content at the permanent wilting point, and it looks like that is permanent wilting point is equal to 0.18. You may have gotten a slightly different answer if you read it slightly differently off the graph, but that's what I got. So the plant available water then is the difference between these two moisture contents. So it will be 0.32 minus 0.18, which is equal to 0.14. That's the water available to the plants. It's water that is in the pores, that is not in excess of field capacity, which is the water that will just wash through the soil, and it's not water below the permanent wilting point, which the plants can't extract. Number 3, will plants be growing at their optimal rate if the soil has a moisture content of 27% or 0.27? So let's go over here. So we want to know, so when we have the permanent wilting point and we have the field capacity, remember plant available water, let me kind of draw that as a line between here. So plant available water lies between here like this. This is plant available water. And the sort of rule of thumb is that within this range, plants will be at maximum efficiency if the plant available water is greater than equal to 50% of the range here. So the range goes between 0.18 and 0.32. So that is going to have the midpoint is going to be exactly 0.25. So this is the midpoint of the range of plant available water. And what we're saying is that if we lie in the region above that midpoint and above, so anywhere in this region here, then we're going to be growing at the maximum efficiency. As we drop below as a midpoint, then efficiency begins to drop off, and when it actually hits the permanent wilting point, the efficiency is 0. The plants can't grow at all. So in our case, we were told, we were told again that the moisture content is 0.27%. So the question is 0.27% above or below that midpoint? And we can see that it is above it. So therefore, we would expect our plants to be growing at maximum efficiency if the soil had a moisture content of 0.27 or 27%. Final question. what would the water pressure be at a moisture content of 0.30? So moisture content of 0.30, let's use a different color here, let's use orange here. So moisture content of 0.30 corresponds to a matrix suction of, it looks like about, oh that's 10, about, is that 2, 0, 1, 2, 3, let's say 3. So the matrix suction here is equal to 3, and the matrix potential, remember the matrix suction is the positive value here, the matrix potential, or the pressure head, is minus 3, and these are meters. So what we merely need to do is convert this value of pressure head to pressure. And remember, the relationship is that the pressure equals rho g times the pressure head. Or the pressure head is the same thing as the matrix potential. So this is equal to then 1,000 kilograms per cubic meter times, we're going to do everything in the MKS system, 9.81 meters per second squared, times our pressure head, which was minus 3 meters. And when I multiply that out, I get minus 29,430 pascals. And of course, only two significant figures here. So we should write this. Final answer is that the pressure at a moisture content of, let's see, write that down, moisture content equals 0.30 will equal minus 29,000 pascals. Negative pressure, that's gauge pressure, so that means that the pressure is less than atmospheric. And there you go.